In this video, I want to talk about vectors in standard position and the component form of vectors. But before we get there, in the last video, we talked about vectors that started at a point and ended at a point, and we notated them like that. Another common way of indicating that we're dealing with a vector is to give it a name like u and writing a vector head on it. So the vector u could indicate some vector. Maybe it's the vector AB, maybe it's not. Lowercase letters with vector hats are pretty common. You'll also see capital letters when we're talking about things like force, or, a nice lowercase a if we're dealing with acceleration. So we'll also label vector quantities with letters, with variables with vector hats. And this is where it's really important to use a vector hat, because maybe I mean acceleration, or maybe I mean just some other variable. When I write this, I mean a scalar quantity, and when I write this, I mean a vector quantity. So again, when dealing with vectors, always include the vector hat, and that way whoever is reading your work knows exactly what you're talking about. Okay, well, in our last video, we learned that equal vectors have exactly the same length and the same direction. And that gives me a way of thinking about every vector as a vector that starts at the origin and points somewhere, right? Because this is the vector AB that points from 1, 2 to 3, 5, but there is a vector that starts at the origin that has exactly the same length and points in exactly the same direction. And thinking about the last video, when I say exactly the same direction in the plane, I literally mean parallel to that one. And so I could think about a vector that started at the origin. And now I need to think about how to create a vector. Well, if I just follow the same path from A to B, right? So I could imagine going over so many and up so many. And literally here I see that I go over 1, 2, and I go up 1, 2, 3. If I follow that same recipe, I should have the same vector but starting at the origin. So over 2 and up 1, 2, 3. I'm going to call this vector u, and the vector u is equal to the vector AB. And that vector happens to start at the origin. And if I think about it that way, that gives me a way of writing all vectors down as if they start at the origin. And so I could actually write down, this is the vector u. And because it starts at the origin, all I need to do is tell you where it ends. And so I use what we call bracket notation, right? This is always a vector. And when I write down maybe vector v points from A to B, I always mean the vector that starts at the origin and ends at the point AB. So v is the vector that points from the origin to the point A, B. So when I write 2, 3 in angle brackets, I mean a vector that points from the origin to the point 2, 3. And what's nice is that is equal to any other vector I would build the same way. So if I just come over here and I imagine a point to start at and I go over 2 and up 1, 2, 3, well, that's an equal vector. I'll call that one W, and then U is equal to U is equal to W, which was equal to AB. Right, 1, 2, 3 equal vectors. They have the same length and they point in exactly the same direction. And nothing changes if I want to talk about a vector in space. So in space, when I say V equals A, B, C, I mean the vector that starts at the origin and then points to the ordered triple in space, ABC. So let's imagine, or let's actually draw a vector in space. So let's sketch the vector 1, 2, 5. So I need to start off with a right-handed coordinate system. So I have an x-axis, a y-axis, and a z-axis. And nicely enough, because if I look at my components here, my vector is going to point from the origin to somewhere in the first octant. So on the x-axis, I need to go out 1 unit. On the y-axis, I need to count out 2 units. So 1, 2, and then I need to go up 5 units. So something like that. And if I just think about drawing lines parallel to my coordinate axes, I should be able to find that point. Or better said, I'll find the terminal point of the vector I'm trying to sketch. All right, so there's the point 125. So the vector 125 would point out to it like that. So there's my vector v that points from the origin to the ordered triple 1, 2, 5. All right, well, let's revisit these component forms. If I imagine in the plane that first vector, so the vector AB that pointed from 1, 2 to the point 3, 5. I had this vector. To write it down in component form, I thought about finding these two lengths, right? So I had the point A, which is 1, 2, and the point B was 3, 5. Well, in component form, if I need to know this length, that's really just the difference in these two x values, right? 3 minus 1 is 2, right? Literally 3 minus 1. And then the length here, the difference in the y values, 5 minus 2 is 3. And so vector AB became, in component form, the vector 2, 3. Right, converting it to that nice happy component form. So one way to think about that is if I wanted to write down a vector that pointed from the point A, which I could think of as an ordered pair x1, y1, to a point B, x2, y2. Right, I can think about the vector AB being equal to some other vector v, and then that vector v in component form would be the difference in the x values, always the terminal minus the initial, and then the difference in the y's, and again, always the terminal minus the initial. In the plane, this is a nice place to remember that if I'm dealing with equal vectors, I'll be dealing with parallel line segments. And if I think about it, if I take this and divide it by that, that's slope. So I need vectors with the same slope to be equal, and I literally see the rise and the run here in the vector's component form. In space, I could think of the component form of a vector this same way, just by adding in information about z. The vector that points from A to B in component form, the difference in the x is always terminal minus initial. And I just do that in all of the same components. So here are my vectors in component form. Okay, in our next video, we're going to talk about finding the magnitudes of vectors, and then I'll introduce you to one special vector.